Um, Before we start, let me ask you one thing. Why did you come here? You came here to learn something new. The reason I ask is because in the original schedule, there is another talk, right? So you came here for Java class reloading, not for the 55 new things in Java 9. Correct. Okay, so we are on the same page. So if you were expecting me to talk about Java 9 and it's not happening, probably you're interested in, I don't know, Android programming or something else. There are some other interesting talks as well. So I'm not holding you back. All right, so we can start. So my name is Anton, and I'm going to talk about various ways to reload Java classes. And there's me. I work for Zero Turnaround. I have a Twitter. If you want to somehow complain to me about what I'm saying, yeah, you can use Twitter. And all of you have been at the keynote, right? Who have been at the keynote? So there is the keynoter himself, so obviously he was at the keynote. And according to the keynote, I am the top of the food chain. Yeah, it's pretty much it's almost like my story. I started as a tester, junior developer, product manager, whatnot. Yes, I am a developer advocate, and according to the keynote, the developer advocate is supposed to talk indirectly about his product. It's not going to happen. I'm going to mention my product directly instead. So nothing to hide. Yes, I'm going to talk about Jerable. I'm going to talk about other things because of Jerable, right? And the motivation of my talk I've got from the Stack Overflow. Surprise, surprise. People are asking interesting questions, and since I work for Jerable, I couldn't, leave this question unanswered. And the person is asking basically, what is the difference between the different solutions for Java class reloading? And can you guess? No? Because there are many answers, many options. They're all very different technically and how you use them. And you can answer this question from many different sides. So for instance, some of the solutions actually require you to adopt some kind of a certain programming model. Let's say if you are using a framework or, I don't know, modules, OSGI, JBoss modules, Play framework, they actually put you into some framework mentality, right? So they expect you to use their abstractions, and therefore they can, do their magic. Or other things like HotSwap or Jerable or Dynamic Code Evolution VM, they are all don't require you to change the way you actually write the code because they are tools, they are kind of ad hoc to your project, and you can throw them away once you don't need them. And you develop your application as normal, but they are technically very different. Some of them are using class loaders, some of them are using the instrumentation APIs, some of them are the patches for the VM itself. So there are different approaches, and I thought it would be nice to cover them all, and not specifically those items that are listed here, but the different approaches how to reload classes, and what are the drawbacks, and what are the technical details behind them. And here I am talking. So the person was asking the question not because he wanted to learn just about the technical details of those projects, but he's asking the question because he is actually he cares about his productivity, meaning the time saved, right? We develop those tools to save some time, to become more effective, and therefore our company actually does some surveys. You can see from the link, it's actually from the past, it's from 2011, but I assure you that the data is not changed much. So if you did the same survey again, it would be almost the same data. And the data says that, okay, how much time you spend on restarting the application, how much time it takes to actually start the application and get it into the state where it's functional. So those guys can get it under 30 seconds, right? The rest Well, maybe not that effective. And there are some, like, this is the tail, like 10 plus minutes. Actually, I have seen times like 30 minutes. So if you have a turnaround time of 30 minutes, it doesn't actually make sense to ask you how many times an hour you can do that. 1, right? Simple math. All right, so what kind of things we are going to cover today? So HotSwap, pretty much standard thing. All of us know what it is, right? We know what it is. No? Damn. All right, so there will be something to learn for you. Class loaders, yes, this is the most popular thing in Java, or feature in Java that is used to reload code, running applications. And we also have Java agents there because shareable, right? Okay, and there will be some challenges that I'm going to mention as well. So let's talk about HotSwap. So this is the thing that is standard in Java. It's included since 2001, since Java 1.4. And usually people think of it as a feature inside the IDE, which is wrong. It's a feature of Java, it's not a feature of the IDE, but we are used to use the IDEs, and the way we are using them, we just don't notice that it's actually a feature of the VM. We see it as a feature of the IDE itself. So when we are using it, let's say we are in the debug session, we are running the application, it prints hello, 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 and we want to add another statement, which is those dashed lines, yeah, just a line. And we recompile the code, and the IDE asks if we want to reload the changes because it sees there are new bytes. We say yes, and it tells us that, okay, one class has been reloaded, and there is no message about that the VM is the one that is responsible for reloading this change, right? So from the user perspective, it looks like the IDE is doing the magic. Well, of course, it integrates with the VM, integrates with via the protocol, but it doesn't actually hot swap it for you. It's the runtime, it's the VM itself that does it. So, okay, we see the new code executing. All right. So, but what if we wanted to do some more changes, not just adding the new statements or anything? So let's say we extract a new method, right? And if you do the same, like recompile the class, say yes again, the hot swap failed, and it tells us operation is not supported by the VM. So the IDE is now blaming the VM. Oh, it wasn't my task, right? It is the VM that is guilty, right? Okay. So how does it look like inside the VM itself? So when you load the class into the VM, or VM loads the class into itself, it actually maps the structure inside the memory so that there is like a structure called the instance class that actually describes the metadata and where all the methods are and what is the class itself. And it refers to the constant pool, right? There is like constants all around it. So if you open the class file, you will pretty much see this kind of structure, of course, in the same file. But inside the VM, it looks much more complicated. The constant pool, yeah, it's a collection of constants, and all the constants are individual there. So if you want to call a method of some kind of class, you have two constants describing this call. One constant is describing the name of the class, and another one is the name of the method. So to actually call a method from the other class, you have to combine two constants, which means a lookup inside this constant pool to combine those, and this operation is kind of, you have lots of them, right, inside the application. So it has a major impact on the performance. Method lookup is kind of slow. So you actually will have to initialize the cache for those lookups in order to speed it up. So it's initialized lazily when the class is first used, but there are more. There's a reference to the array of references that reference the true methods. So this part here actually contains an individual method, basically body, what is executed. And then when the just-in-time compiler actually runs, it compiles those methods into the native code, where you have this assembly code executing, and they are all interoperating together, right? So actually, to make a small change here, you're affecting different regions of the memory just by adding a single statement. When, ooh, damn it. Okay, they are going to cut it off, so whatever. All right. So if you're adding a single statement, you're changing this guy here. It has the effect on the constants pool because I added a constant when I wanted to add, like, print a new string. I'm actually adding a constant. Or if I want to call to another class, it will be already like adding two constants, right? Then I have to drop the cache. Then I have to drop the compiled version of the method and recompile it again afterwards, and so on. So you see, like, just adding one single statement actually affects the whole memory region. And if I wanted to do more, it actually, is more complicated than this. And this is from 2001, and it's still like this today in our favorite VM. So what if we wanted to have a better HotSwap? So there is a paper, and there is like a prototype implementation, of course, of it. The Dynamic Code Evolution VM for Java. And the paper is from 2010. So the Oracle Labs is responsible for it. So statements is the simplest type of change that I just mentioned and described in this diagram on the previous slide. And what if you wanted to change the method or adding a new method? Adding new method actually means that you have to change the collection of the embedded methods inside that leftmost structure, meaning that you have to change the indexes of the methods inside the class. The lookup will be different and so on. So that's already a bigger change. Next, if you want to add fields, that becomes even more complicated because until now, you only were changing the description of the class, but if you're starting to change the fields which contain the states, it actually means that you are going to the instances. So like before that, you only changed the class description, that's the metadata. Now you're changing the fields which concerns, like is related to state, and state is inside the instantiated objects. It means that you have to somehow transfer the values. Like the whole point of HotSwap is actually preserving the current state of the operation of the program. So you have to preserve the values, which means you have to adjust the layouts of the objects inside the memory, and for that you have to modify the garbage collection. So, and garbage collection means not only just collecting the garbage, right? It actually means allocating memory as well. So in that prototype, they have a modified version of garbage collection inside the VM to support this. And the most complicated thing to change is the hierarchy, because not only if you change the superclass, you are affecting the positions of the methods inside the tables, you are affecting the fields somehow, you may affect them. You are also affecting the metadata inside the existing classes you have to reflect the new relationships between the classes, between the types, to reflect, that here, hey, there is a new superclass actually on my existing class. So if you change A extends B, you are changing it to A extends C, you have to reshuffle all the index tables, you have to refresh all the metadata related to it, and so on. And there are two types of changes which are, different changes. You may add methods, you may remove methods. So if you're adding those, that's not a big problem. You just refresh the metadata. But if you're removing something, it means a binary incompatible change, because if at runtime, you remove the method, which is used by another class, right? So it breaks. So you have to ensure how to fix it. So just having HotSwap like in your tool set will not actually help you much if you want reliably to update the code. For that, you need tools. And our applications, they are like they're like this, right? They are not beautiful and shiny, consisting only of true objects and They have all kind of configurations around it, XML, annotations, frameworks, and so on. So it becomes even more complicated. And let's talk about some other dirty stuff here. Class loaders. Did you have to implement a class loader yourself, ever? Right, nice. Did you have problems with it? Yeah, someone is laughing. Of course you had. Okay, let's start with basics. So we have a class which has a static field there, age of 10, and we can load it from two different contexts. Let's say one is like from the current context, and then we are loading with some custom class loader. So we have two classes there, but they are like different. They have the same name, but they have a different class loader, which means they are actually different classes at the runtime. And so if we are changing the value of the field inside this class, we will see via reflection that this has changed only for that instance that was in the context, in the current context, that the field of the class that was loaded through the custom class loader wasn't changed, right? So it shows us the isolation, meaning that we can, have two different versions at the runtime at the same time and so on. Okay, let's make it a little bit more complicated. We have a user that has a hobby, and it's basketball for some reason. And think of this while loop as a life cycle. It's not like in a true application, right? But we have some kind of life cycle inside the application, and it has a start and stop. So in between, we can just load the user class, like dynamically into the class loader, because it's a new instance of that, and use it. So every time we actually are reloading this class, right? We have a new instance of that class inside the application. That's something already. We are reloading the class, right? And there might be a question: when is the old version discarded? Right? The moment you don't have the reference to the previous instance of the class loader that loaded that class, it can be garbage collected, right? So it's all legit here. And okay, let's make it even more complicated. We have let's have some sort of a reloadable region. So we have a context that can be reloaded at once. So multiple services could be reloaded at once if you have many of them. And again, in the while loop, we can just load this whole context into the same class loader, create the instance, initialize it, fine. So once we need to reload it, it reloads the whole region, many classes at once. Does it remind you of anything? So we have one class loader referencing multiple objects, or multiple classes with the instances, and once we don't need it, we drop the class loader, load the classes again, create all the instances again, we have the new version running. Does it remind you of anything? It reminds me actually of Tomcat or any web applications, right? So when you want to reload the application or redeploy it, the web container will just drop the class loader, web class loader, and create a new instance of it, load all the classes again, call the init method on the servlet, right? Okay. There's another guy who's using it almost the same way, but with some magic. Are you using Spring Boot? Any of us? Yeah, everybody. Are you using DevTools in Spring Boot? No. There's a neat little project there that you can configure. So let me show you. So I have this demo application, the standard one. I actually hate it. Because it's always the same, And so inside your POM, you can actually configure a dependency on the DevTools, the DevTools dependency. And when you start it, what will happen is that the DevTools will be configured automatically. And when the application starts, the DevTools is figuring out which classes are actually eligible for reloading. So they are changeable, so you are working on them. Basically, those are the classes in my project tree, right? And the other classes that are in the libraries, they are not reloadable, so I'm not going to change them. And it's not going to load them into separate class loader. And therefore, it doesn't have to restart or load them again when it needs to reload the application. So let's check here. So we have started at something like 28 seconds, right? 34 seconds, 6 seconds, right? It's pretty fast to start. So let's see. We have an application, I think, localhost 880. So it's running. It's operational. It does something, right? So we have this URL here, owners/find. So just to show you what will happen when I change something. And let's make a change for that part of the application. Where is that? Owners, edit. Where's find? Yeah, find is here. So if I change this annotation value here, search, and recompile, let me actually show you in the console what will be happening. So I recompile the class. So the file system listener, is listening for the updates of the file system there. It will see that there is a timestamp that has changed for that single class, and it will restart the context of the framework inside my running application. So it actually did not restart the server, and it was able to reinitialize the application, as you can see, in less than 2 seconds, right? Here. So nice, isn't it? And my application is, if I go back, I will find owners. You see it's not available on that old URL, but if I change it, it's there again, right? It's nice. It's good until your context, the application context inside your running application is not too big, right? It's because it's restarting it fully. If initialization of the context takes time, then restarting it fully will actually, delay in time spent for you. Okay, so did you learn anything already? Nice. Okay, so that was the thing. So if you want to try it, it would be interesting to hear the feedback if how it works for people on real life projects. Because on a small project, of course, it just blazing fast. But once you have a big project, probably it's not so fast anymore. Okay, but if you go to the documentation of this tool, right, inside Spring Boot documentation, you will find this interesting description about restarts versus reloads. And let me read it for you. If you find that restarts aren't quick enough, meaning your context is big, and you encounter issues with class loaders, oh, really? You could probably consider something else, like Jerable from zero turnaround, or maybe Spring Loaded, which is not commercially supported. Just let me zoom it for you. Okay, so they mentioned two things: class loader issues with the class loaders and the two agents, right? So issues with the class loaders, yes, they are there. As you can see, they are being closed and they are from the past, but this is like a moving target. They might appear again. Let's talk about agents. So since we mentioned Jerable there and Spring Loaded, agents are based on the Java agent technology, right? So when you can start the application with -Java agent, it kind of lets you into the class loading. So you can hook into the class loading phase and do your magic with the classes before they are actually defined by the class loader. So how many of you know about Java agents? How to implement those? So there isn't an interface that you have to implement to make this class a Java agent. There is like a convention. There is a pre-main method. Sometimes you can implement an agent main method if you want to attach to the JVM, but it's not our use case right now. So, but actually to tell to the JVM that this is the agent, you have to package it properly. in the manifest, you have to say which is the class that actually implements the agent, which has this pre-main method. And then when you start the application, you will have to configure the -java agent and the path to the jar, which implements the agent itself. So inside that agent, you are provided with the instrumentation instance, which is provided by the JVM itself. And this is your hook into the class loading phase. There you receive all the bytes that you want to transform during the load time. So when I implement this class file transformer, it actually gives me, I have to implement just one method there that takes in the bytes, and then you can use any of the libraries for bytecode instrumentation to, add new methods, change the signatures, or whatever transformations I want to do. So this gives me the ability to prepare the classes that are being loaded for reloading afterwards. So when I want to change them, all the preparation is already done. I can just, change the versions. So what is described in the PhD thesis of the creator of Jarable is the same transformation trick, so that when you are loading one class into the memory, like into the JVM, it actually is split into two classes. The first version that is like on the top there, that basically has the same shape, has the same fields, has the same methods as the original class, but there is also like a versioned class that also has the same methods, or basically not the same methods, but like true body, like true instructions that you implemented in the original class. This first class that has the original shape, it actually delegates all the calls to this version class. So once we have this new version, like we change something in the class, we recompile it, we load it again into the JVM, we can actually switch, we can keep the original version and then just switch to the new version of this changed class. So let me give you an example. I try to explain, like in very simplistic manner, how it's described inside the paper. So in the beginning, let's say we have this original class that class C extends X, and it has a field and two methods, right? And one of the methods is actually using this field. So after the transformation, what will happen to the original version of the class is that the field is preserved, it's still there, but the methods will be kind of rewritten in order to be able to delegate to that version class. So the method 1, well, it will use the runtime. It's kind of a pseudocode here, so runtime of Jarable to redirect the code to the original method that was in the original class, but now it's moved into the versioned class. So it just calls the method 1 of class C with signature that takes in the parameter as integer and returns an integer, right? So it's the same signature, but it's kind of a level of indirection. So by solving any problem, like to solve any computer science problem, you can just add a level of indirection, right? So basically here we just rewrite the original methods to delegate the calls to the something that is supposed to execute. And the versioned class, that is a new one, that is not supposed to be instantiated, there shouldn't be instances of that class. It's actually doing the real work, right? So it actually gets the value of the field that was in the original class, right? Because the field is, like, remember, it was there, and performs the original operation that was described in the source code. So it's x plus y. So that's the simple indirection that is, applicable to this simple implementation of, of your program. Of course, there are like much more complicated versions of it. And the same is here. That's the original body that is supposed to execute. And there we have to make the redirect again because there are some platform classes, and we call them indirectly again, so using the runtime. So when you want to change the original class, remember we had this just two methods. I didn't print out the two methods, but just the field and the method one. And we are adding the new method there, right? We are adding this method z that is returning a constant. And how will it look like? Again, we are loading the new version of this class, right? And now we are actually using this new method inside the original method. So we actually have to add a new method and rewrite the old method here again. So what will happen, we will load this compiled class again, split into two versions again, throw away the original class because we have it loaded already. It's the same shape, it doesn't change. But we have a new version like C1 instead of C0. So now all the redirects should go to the new version. So instead of C0, we are going to call C1. And it has the new method body, right? So it has all the new statements there. And it has all the new code, basically. So let's make a quick demo here. Any questions so far? The benefit is that you can load as many new versions as you want dynamically. You probably can. You probably can split, like do it without splitting, but I couldn't think of another way to do it. Like I'm just describing how it's done right now. We can probably discuss it afterwards. But yeah, I probably don't have a good answer why. It's just the way it's done. Yeah, another question? So what's about performance? Of course, on the indirection, because you have another layer of indirection, it's the performance hit, but we are not talking about production here. It's a productivity tool that you don't have to care about the performance as much. You would care about the performance if it's a noticeable impact when you're reloading the application and it reloads so slowly you cannot wait, right? But it's not the case with invoking the methods. Right. Okay, let's go forward. So let me show you some kind of demo here. So we have, I probably have to change the fonts a little bit. Font 28. Math skills. Okay. All right, so we have a loop there, right? That is calling to a method A of class A, which is like a simple thing just to demonstrate how it works. And class A will actually call to class B, and class B is printing out something, right? So let's start with it, and we will see. I will make small changes, and we will see how it actually progresses and what will happen there. So let's start with Cherable. So it's printing once every 2.5 seconds. It will be printing something, and we will see when I'm changing, it will be reloading, and we will see the results there. So let's start with the simplest changes here in the method B. So for instance, if you are changing just a constant, right? We are reloading a constant. We are reloading the method body. We have to do small changes in the in the caches and so on, and you see it's already reloaded, and we have the new result being printed. So what if we start doing bigger changes, like extracting a method? Okay, so well, it reloaded, but we didn't see the change. But just to add something there, right? So the new result is there. or we could remove it in line and change these guys so we have this old version of the code running. Now if you want to make like more complicated changes, let's say we want to class B to extend class C, right? And class C has this another version of method B and some sort of a field constant there. So let's make a change. Extends class C. So it will reload, but will be printing the same result, right? Because it's overriding the superclass, and we have the same method there, so nothing changed. So we can actually safely remove the method from here, and once it's reloaded, we can see that the new version is being printed there. So it actually is calling the method B from class C, and it's incrementing the state. What if we add a new field? So D, and let's print it out as well. Boom. See what's happened? Like the old value is still incrementing in the same way. It wasn't dropped, it wasn't reinitialized, it wasn't turned into 10 again, but the new value has initialized with the with the value that I've set in the initializer. So that's the smartness about reloading the classes. You have to preserve the state you had before, and being able to initialize the state that you just added, right? Because if we did not initialize this field D, then it would be 0, right? So that's a big trick here, because they are basically in the same constructor. If you think how the fields are initialized, they are actually initialized inside the default constructor, right? There is no any magic code that takes 10 and somehow puts into the field. It actually, when you decompile the class, you will see that it's all in the same code block. It will basically mean that you removed the field and added a new one, right? But it's not all, right? We have a hierarchy. We have a class B extending class C. So what will happen there if we remove this guy from here, add it into B, and start printing it here, and in class C we will just not print it. Let's see. It recompiled both classes, but it's printing still this D starting from the correct value, right? Let me fix this a little bit. So B. Right? You see, it's when I moved this field with the same name through the class hierarchy to the basically to the extending class, right? It still preserved the value. Any questions here? It's a feature.
So it means if we will change the name, we will rename it back. It will continue from which state?
From the state it had previously. So yeah, if you
sorry, and what will happen if it will be the private field, let's say?
It doesn't matter. It's the same. Yes, it caches the fields, of course. Yes. So yes, the next question would be what kind of extra memory you need for that, right? Of course, you need some. Okay, let's stop it here. How much time? We have 5 minutes. Okay, so that was like a small demo of reloading the classes, and This is like the prerequisite for the whole thing, actually, because your application doesn't consist only from Java code. Your applications consist of property files, framework configurations, some kind of metadata, whatnot, what kind of architecture you build. That is why your real projects are like a real, I don't know, dirty stuff, right? And every time I'm talking about Java, people actually start asking, what if I add a new bean to my Spring context? Sure, why not? What about configuration, right? Because adding a new bean is actually changing the configuration of the framework and the whole application, and then it has to be reinitialized. That is why the dev tools actually is just restarting the context, because it has to scan the context, like the Spring context, Spring configuration again, rewire everything, and then, you know, then it would work. So how Java copes with it? Spring Pet Clinic, the same app. For it to work, I actually have to remove the dev tools because they will conflict. And if I start with Cherabo here, let's see. Right. So it tells me that on the start that the directory here is actually is monitored for changes. So Java is monitoring the changes here. And once it starts, let's say we have some kind of a old functionality that is broken from the previous demo, but let's fix it. Owner controller, it should be find instead, right? And recompile this single class here, so I'm not rebuilding the whole. Oh my god. What happened here? Cannot find? What am I doing here? Okay. Let's fix it this way. Probably. Sometimes it caches the old resources, and I have to run the Maven compile again. And probably I have to check if it's not Java 9, because I was playing with it just a minute ago as well, just before the talk. So let's see, it starts. Okay, so it's there. Find owner, the application works, the classes are already in the memory. We have a form that is, you know, somehow validated here, and we have the main object that is annotated with some like bean annotation properties. And if I change that, let's say I don't want to validate the phone number, boom. And it was only reinitializing that single class, the proxy that is, you know, for the JPA proxy, and yeah, and it has reconfigured the session factory because it's related to Hibernate, and we have the new behavior inside our application. So as you see, it wasn't restarting the whole context. It's much faster. So it doesn't have to play around with the class loaders, like drop the old class loader, create a new instance, read all the configurations again. So it actually doesn't have to do that. That's why it's faster. Okay. We are almost in time. And if you have questions for me, I will be happy to answer those, but just before that, to recap, we have learned that HotSwap is not the feature of the IDE, it's the feature of the runtime, right? You can use class loaders, but to reload the code, but it has some kind of complications, or it actually will change the way you are developing the application because of the programming model, like with modules or OSGI or whatever. And there are some other tools that can help you with this task without changing the code. So if you have more questions for me, I take them now, I take them later, I can answer them on the email or on Twitter, so just go. No? Questions? Yeah.
Please wait the microphone.
Okay, the question is that my biggest concern would be, okay, but by injecting, for instance, JRebel, how to put it, interceptor, I would say, or some embellishments on top of normal class loading, aren't you putting yourself in a situation when you will have to actually utterly retest the whole production code at some point, because you obviously are not going to put JRebel in production, right?
Yes, it's just a development time tool, and you are not going to use that in production. So what is the original problem here?
The question is actually, I mean, what is the benefit of JRebels, and in a sense that you will still have to retest everything when you will consider that code is more or less ready?
The benefit is, like I mentioned in the beginning, all the tools are actually created to save time, to increase the productivity. Right? So if your redeploy times are slow, you have to, your style of work is that you make a simple change, you want to test it, right, inside the application. And especially if your change actually is related to the full stack, right? It covers the UI, the backend, like the controller, the database access. It will be like through the application, and it's very hard to cover with tests, right? Because normally you would argue that I can write unit tests, of course, right? It's not mutually exclusive. You can write tests and you can test your application like functionally, right? So if your redeploy times are too slow, you are tending to batch the changes. Like you make one change, second, third, fourth, fifth, then you restart the application and test them, right? But then you may break much more things. So it's much better to test small things, right? Small changes, and kind of JRebel supports this kind of workflow.
Thanks, and maybe any numbers about it?
The numbers?
How much does it save time, some percentages or whatever?
Well, it's very hard to calculate how much time it actually saved, right? We let you to count how many times you actually used some JRebel, but it has a very interesting side effect. Imagine your redeploy time was 10 minutes. But in those 10 minutes, when you started to use JRebel, you made the redeploy 3 times. So in 10 minutes, you saved half an hour, which doesn't sound like realistic enough, right? Because it actually changed the way you develop. And well, it's hard to say. To some people, it's just invaluable. To some people, it will be like, okay, I'm not updating my application too often. Once an hour, probably my restart takes 1 minute. It's not a justification for me to use JRebel then, right? Any other questions? Yeah, here.
Where is the hand?
What happens to different execution contexts and sessions and stuff, like connected indirectly to the class instances? For example, in many transactional systems, there are connection between session of the request and the instances. So what happens when you reload the class which has the connection to the session? Does session preserve or not?
The session is preserved, that's the whole point, right? So when you are developing, you are making the change, you don't have to log in into the application again, like navigate several screens, fill in some form and then see the result, right? You are staying on the same screen, the session is preserved. The whole point of this indirection is that we keep your instances in the memory, so you don't have to recreate them. right? Any more questions?
My question is, will be all mediation and proxifying code removed when I do normal restart?
Can you repeat, please?
Will all mediation code and proxifying code, which is inserted by JRebel and class loaders, removed when I do normal restart?
Yeah, of course, those all the indirections and instrumentation is added dynamically. So when you start with the agent itself, it will add them. If you remove the agent and you restart the application, then it's not there.
So everything will be normally recompiled and...
Yes.
Okay.
Yes. So
thank you.
it's not something that modifies your application like persistently. Like. No more questions? Okay, you are probably just too shy, and we can use the time afterwards. So.
Thanks a lot, Anton.
Thank you very much.